Well, day 3. This is going to be my last big topic video. If you want review or if you want lots of review, www.mrkrause, Krause, math.com. It should be in the show notes as well, or in the comments as well. So you should be able to find my website. Click on Regents Review. All of New York State Algebra 2 Regents exams are solved and explained in video, broken down into 3 parts each exam. I have now 9 different topic review questions. Each video has 2 or 3 different topics in it, so there's lots and lots of review on there for you. This is going to be my final one. It's a shorter one. It's only got 23 questions on it. We're going to cover forces, inverses, inequalities, and the quadratic formula. And I believe if we do the quadratic formula, there might be an opportunity to do some completing the square. At any rate, let's get started. Let's see if my pen works. It's always the big question whether or not that's going to work very well. Still looking for that new computer. No. By the way, if you like what you see and this helps you at all, please hit the subscribe button. If you've already hit the subscribe button and it says subscribe, don't hit it again. You unsubscribe. That's not good. But if you've already hit the subscribe, hit the like button. Not the down button, the like button. Remember what I said. If you hit the down button because you don't like my video, you know what that means, don't you? It means your grade's going down. And I don't want your grade to go down. I want your grade to go up. And hopefully you're getting a lot out of my videos. I'm just trying to expand my viewership so that, again, like I said, I can get some more privileges. And I think I'll let you know at some point soon I will be monetizing my videos just to get some commercials and maybe pay back some of this huge studio costs I have. At any rate, guys, let's get started. We're going to start with a forces question. Although it doesn't say forces, generally it says forces. I don't know why I picked a non-forces question. It really is a forces question. It says, this is a tricky question. It said, and you want to bring your highlighter to school. And by the way, there's a great opportunity for, this is a great opportunity for highlighters and colored pens. We got 20 and 40 degree sides, and we have 120 angle between, and we want to find the exact area in simplest form. Well, I always tell my kids to draw a parallelogram, not like that. What you want to do is you want to draw your short side, your long side, and your shorter side, and there's always one shorter than the other. Now, I think I'm going to have a change of heart. I was doing something I don't really like. I'm going to call this 20, and I'm going to call this 40, but clearly this is my 120 degree angle. Find the exact area in simplest form. We only really have one area formula that we are going to be using. Oh my goodness, I got all kinds of stuff on here. This from the last video. Only one formula that you need to be recognized and using, and that's this one. But it's the area formula of a triangle, not the area formula of a parallelogram. But don't forget the laundry's done. Don't forget that a triangle or a parallelogram is really just 2 triangles. So what we're going to do is we're going to use that formula. Area, I don't hate the word K, equals 1/2 A times B times the sine of the angle in between. By the way, I don't know why I put 120 there. This is 120. This is just 20. The only thing we have to do is get rid of the half because there's 2 of them. We'd end up multiplying by 2 anyway, so we might as well just do it. Now, the big thing is this exact area. Don't you dare type this in your calculator. You're going to have to use your brain. So 20 times 40 times the sine of 120. Well, 120 has a reference angle of 60 degrees, and the sine of 60 is the radical 3/2. So if you put this in your calculator, you're going to get some redunculous answer, when the real answer is 400 radical 3, right? 2 goes in there 400 times. All right, that's it, done. 1 out of 23 done. 22 to go. The measure of the angles between the resultant and 2 applied force and the applied force. 2 applied forces. So we got an applied force. We got 1 force going this way. Anybody could tell me why these pop up all the time, I'd appreciate it. And then 1 force here. All right, and that's going to finish. Anytime you see the word force, I want you to draw a parallelogram. That's what you're going to draw, is a parallelogram. Arm sticking. Got to get out and walk. All right, so Let's see. We've got, now wait a second. It's the resultant between, it's the angles between the resultant and the two implied forces are 40 and 55 degrees. So what I'm going to have to do is draw in the resultant. Now the resultant is this diagonal, right? We've done this a million times, I'm sure. So I look to see this one is bigger than this one. I've got 40 and 55, so I'm going to put those in the right place. 40 degrees and 55 degrees. Well, that's what, 95 degrees. That leaves me 85 for here, because these 2 angles have to add up to 180 degrees. Okay, the magnitude of the resultant is 30. So I want to put that in. The magnitude of the resultant is 30. And what the question says, find to the nearest pound the magnitude of each applied force. Well, this is also going to be 55 degrees. That's just, if you add up 40 and 85 and 55, they add up to 180. So this is going to be, since I only have one side and lots of angles, this is a law of sines question. If you came over to your law of sines, you'll remember that the law of sines, so we're going to be mostly using the law of sines and law of cosines, is the side over the sine of the angle equals the side over the sine of the angle equal. You only need 2 of them. So we'll go back, and that's not what we want. That's my YouTube channel. Oh. What we want to do is I want to call one of these x and one of these y. So what I'm going to do is I'm going to do 30 over the sine of 85 is equal to, and let's find y first, y over the sine of 40 degrees. And we will cross multiply. So I get y times the sine of 85 is equal to 30 times the sine of 40. Divide by sine of 85. So, and I grab that 30 sine 40. 30 sine 40 over the sine of 85. 19.357. So y equals 19.357. Nearest pound, y equals 19. Don't have to put units. Let me grab a different color. X over the sine of 55. Notice it's always the side and the angle opposite, or the side and the angle opposite. And always go back to the one that you were given. The one we were given was the 30 over the sine of 85. So this is equal to x times the sine of 55 is equal to 30 times the sine, x times the sine of 85 equals 30 times the sine of 55. And then we divide by sine of 85. $30 times sine of 55. Right, so it's basically this exact same thing. 30 times the sine of, but in this case it's 55, and I get 24.668. So 24.668. That's what x equals. So x is equal to 25. So those are my 2 pounds. 19. My 2 forces, 19 and 25. I don't know why I said that. I didn't realize we were going to do so many area of the triangle or parallelograms, but they're all same work, so might as well do it. Parallelogram, I've given you the area equals 800. The lengths of the sides are 50 and 60. And I want the nearest time to measure the acute angle. That's this one. Acute little angle. There it is. So I'll do the formula. Area is equal to, by the way, if you ever use 1/2 base times height on a trig regions, slap yourself silly. It's kind of dumb. It's 1/2 AB sine C, except we don't have a triangle, so we get rid of the half. So 800 is equal to 50 times 60 times the sine of C. Divide by 3,000. because that's what 50 times 60 is. And I get the sine of C is equal to 800 over 3,000. Now I want C by itself, so I'm going to bring that sine over, and I get C is equal to the inverse sine of 800 divided by 3,000. No problem. Sine inverse, 800 divided by 15.46, rounded to the nearest what, tenth? So this is C equals 15.46, so C equals 15.5 degrees. All right, page 1, done. Two forces of 45 pounds and 30 pounds act on an object. Boom. I hear the word forces. I draw a parallelogram. One longer, one definitely shorter, and on an angle. Don't try to draw a rectangle. Yes, a rectangle is a parallelogram. Yes, it will confuse you. And yes, my phone just went off. Do you like that? It's like my communicator. Beep, beep, beep. Totally useless email. Don't know why it went off. So 33 pounds, I apologize, and 45 pounds. Nobody email me and say, put your phone away while you're doing videos. Are you rude or what? I don't want to hear it. Shut up. You and I are going to fight. Whoever said that, I heard you. We're going to fight. Come on over. I'll tell you where I live. I live in Spencerport, New York. It's near Rochester, New York. Anybody from Spencerport, give me a shout out. By the way, I live right down the street from the high school. Right near the creek. That's all I'm going to say. There's 33, there's 45. Let's see what else we got. The angle between the two forces is 55 degrees. I want to find the magnitude of the resultant force to the nearest pound. I'm just going to do that first. So we're going to find this. It's kind of tough. I do know what this is because the 55 and whatever this is have to add up to 180. So this has to be 125. So I have here side, angle, side. Now, if you have side, angle, side, I'm going to tell you right now, you have to use the law of cosines. The law of cosines, if you have side, angle, side, or side, 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 you will use the law of cosines. Now, what A and B and C are don't make any difference. Oh, I keep doing that. What A, B, and C are really don't make any difference. The big thing is the things you're looking for have to be on the end. So I'm just going to call this A since it makes it a little bit easier. And this little A, and for fun, I'll call this B and C. All right, so formula is A squared equals B squared minus plus C squared minus 2BC cosine A. You want to know what some of the biggest mistakes made are? Cosine A, by the way. Forgetting this 2 and actually using the law of cosines and writing a sign there. Or just clicking on sign on your calculator. It's so automatic. So I'm going to look for that thing I called x. So that's really my A. X squared is equal to, and then I just use these other side. 45 squared plus 33 squared minus 2 times 45 times 33 times the cosine of 125. Now the good news is these are all numbers. They are all numbers. So I can just type those into my calculator. And that's not too bad. 45 squared plus 33 squared minus 2 times 45 times 33 times the cosine of 125. Now you don't want to round this. 4817.5220. That gives me enough that now here it said we're going to, oh, that's x squared. So in order to get the whole thing, I got to take the square root of that. So take the square root of the answer. 69.408. 69.408. Nearest pound, x equals 69. I thought I changed this problem. Okay. Now it said, using this answer, find the measure of the angle formed between the resultant and the larger force. Now, I'm certain that there are a number of you, when I read that, using this answer, find the measure of the angle formed between the resultant and the larger force to the nearest degree, understood this. Wenn du hast diese Antwort, du musst die große Angle von dieses Bild gefunden. That's my really poor attempt at saying something in a different language, German, and having you go, what the heck did that guy just say? What? I don't even know what that means. You got to break it up into things that are simple. So I'm going to use my highlighter because highlighting is fun. So I want the measure of the angle between the resultant. So I'm just going to highlight that resultant. There's the resultant. And the larger force. Oh, I just drew an angle. So what they're really asking for you to find is this little angle. I'll give you a hint. It's less than 55 degrees because they both add up to 55 degrees. I just got to figure out what it is. Now, in order to do this, I'm going to use the law of sines. And it said using your answer. So I'm going to use the 69 I just found. Yes, 69 came up in a math problem. Oh my God, that's so funny. That's the beauty of teaching juniors. You don't really get that anymore. I taught freshmen for so long, I almost became one. That's why I act the way I act. I'm a little weird, I know. Don't start emailing me. So 69 over sine of 125 is equal to, now I want to find this angle, so I have to use this side. I know that's counterintuitive, and they said between the larger force, but the larger force is opposite the larger angle, but that's not what we're looking for. We're looking for this actual smaller angle. So that means I'm going to do 33 over the sine of, we'll call this B. So 64, 9, almost screwed that up, times the sine of B is equal to 33 times the sine of 125. Now I'm almost done. I'm getting there. I'm going to divide. I still need to get this b by itself, so I'm going to divide by 69 and divide by 69. And my last step is I need to get this sine over to this other side. So when the sine goes to the other side, you'll remember that it really just changes into sine -1. It changes its sign, so to speak. And so I want to take inverse sine of 33 times the sine of 125 all over 69. And so that is what I'm going to put in my calculator. Control division, just in case you're wondering, that was my little dog, Ruby. And I'm going to guess my son just came home. Anybody care? No, nobody cares. But that was her barking. My big dog doesn't bark unless the mailman comes. And then he likes to say hi. Okay, so I inversed. Oh, I forgot to inverse sine this. Son of a gun. Let's see if I can do this. All right, complete mess. So delete, 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 mess. Come on, delete. All right, so I'm going to inverse sine, control division, 33 times the sine of 125 all over 69. Enter. 23.0645. So 23.0645. And I want to round it to the nearest degree. So B is equal to 23 degrees. That's it, kids. That one's done. That was a tough problem. Two sides of a parallelogram. Find the length of the shorter diagonal of the parallelogram to the nearest centimeter. Okay. So we're going to do a 50-degree angle. It's a small angle. It's a cute little angle. You get it? A cute little angle. Less than 90. 25. And yes, I drew this completely to scale, 30. So I want the length of the shorter diagonal. So as I drew this, do you see how this is the smaller angle? Right? It is, and that makes this that makes this the shorter diagonal. So, what am I going to do? Oh, I just want to find that. That's all I want to do. I just want to find this. So this is side, angle, side. I use law of cosines, and I'm looking for x. So these two things have to go on either side of each other. So x squared is equal to 25 squared plus 30 squared minus 2 times 25 times 30 times the cosine of 50 degrees. Now the cool thing is, baby, I just typed that in my calculator. I love the calculator. The calculator is my friend. 25 squared plus 30 squared minus 2 times 25 times 30 times the sine, I believe, of 50 degrees. Sine of 50 degrees, right? What did I do? I used the law of cosines and put the word sine in. You see how easy that was? And I'm going to tell you right now, I didn't mean to do it. And then all of a sudden I realized I was using the law of cosines, and I clicked on sine. Like, really? Seriously? It happens all the time. What am I going to tell you? Check your test over. That doesn't mean just look at your work going, oh my God, my work is beautiful. Oh, it's lovely. Lovely work. Look at the way I made the 5 and the 0. It's like a perfect 50. It's gorgeous. That's not checking your work. Check your work means, I can't see it. Don't look at it. Don't look at it. And just redo it and be like, bam, same answer. That's a check. I don't care how neat it is. Actually, I do a little bit, but not tremendously amount. 560.818. 560.818. Don't round. 5847. I believe that was right. 5847. Now, in order to find x, I'm going to take the square root. So I take the square root. By the way, do you all know a fast way? You want to know a fast way to do this? Oh, enter. Fast way to take the square root is just raise it to the half. Because isn't 1/2 a square root? 23.6816. Forgot what I said already. 23.6818. So x is equal to the nearest centimeter, 24. All right, so how does one go about finding an inverse? Well, I didn't leave you a lot of room here, so it must not be a very difficult process. So let's talk about inverses. Inverses are reflections over the line y equals x. If you're given a table of values and they ask for the inverse, just switch them. If you have an x column and a y column, and I tell you, what's the inverse? Take the two things and switch them. That's it. Boom. How do you tell if something's a function? Well, you could say it passes the vertical line test, but you don't have any repeating x values. Now, how do you know it's a one-to-one function? Well, that means the inverse is a function. Otherwise, wait, let me think about this. If I switch the x and y around, right, the y's are over here now, and the x's are over here. But I don't want to have any repeating values here, because if I have any repeating values here, it's not a function. So in order for it to be a one-to-one function, I can't have any repeating x values, and then when I switch them, I can't have any repeating y values, and that makes it a one-to-one function. In terms of finding an inverse, that whole switching the x and y, that's what you got to do here. The first thing you got to recognize is the fact that f of x is really just a y. So if I want to switch the x and y, I'll just write x equals, it's just the letters, none of the other crap with it, just the actual letters. So x equals 1/3 y minus 4. Now, I don't deal with fractions very well. This little son of a... That's all, folks. Drives me crazy, so I'm going to get rid of it. It actually doesn't drive me crazy. It drives you crazy. And because it drives you crazy, it drives me crazy. And if you're crazy, I'm crazy. And if we're all crazy, then I'm crazy. So I'm going to get rid of that crazy thing so nobody's crazy. See what I'm saying? The beautiful thing about fractions is you can get rid of them relatively quickly. I look at all the denominators. There's only one. It's a 3. I want to get rid of it. So I'm going to multiply this side by 3, and I'm going to multiply this whole side by 3. Because that's what you have to do to make it legal. So what do I end up with? I end up with 3x equals y minus 12. Well, to find the inverse, you have to get y alone. So I just have to bring the 12 over. 3x plus 12 equals y. Now, you're not in 4th grade anymore. You got to give me your answer in grown-up fashion. Grown-up fashion says you're going to write f inverse of x is equal to 3x plus 12. That's it. All right, let's try this one. It's got a radical. I'm scared, Mr. Krause. Okay, g of x is the same as y. So I'm going to switch the x and y, so I get x equals square root of 2y minus 5. Well, how do you get rid of a square root? Because I don't even like square roots. The easiest way to get rid of a square root is to square both sides. Well, this just becomes x squared. And remember, a square and a square root say goodbye to each other. So this side just becomes 2y minus 5. I still need to get y by itself, so I'm going to bring the 5 over, so I get x squared is equal to, ooh, what in the, that's all, folks. X squared plus 5, I'm going to bring that over, is equal to 2y. And now I'm going to divide by 2. Divide by 2. So my final grown-up answer is g inverse. G, that's a lovely function. G, math is hilariously funny. G, I nailed this question. X squared plus 5 over 2. Nailed it. K inverse. So remember, K of x is also, here's a surprise, it's a y. Oh my God. That's crazy, man. Crazy. Let's switch the x and y. X equals 2x minus 4 over 3. Bleep, bleep, bleep. Don't lock the denominator, sir. Let's get rid of that denominator then. Let's multiply both sides by 3. I know you're thinking you're just cross multiplying, Krause. I know. I'm not stupid. I'm just bald. Did you just call me bald? Man, you and I are fighting again. 3x is equal to 2. This should be a y, kids. This should be a y. I switched x and y. It should be a y. So 2y minus 4. Notice the 3's canceled. And it should be 2y minus 4. I think when I drew that 4, I thought it was a y. So I still have to solve for y. So I'm going to bring the x over. 3x plus 4. I got to focus and stop screwing around. Is equal to 2y. And divide by 2. And divide by 2. And I've got y by itself. But I'm going to be a grown-up. I'm going to make him think, man, that guy's a good student. He's going to write k inverse of x is equal to 3x plus 4 over 2 bagger. Box it in. Check it off. Write your teacher a little note. Mr. Math Teacher, just bubble in 2 points. I nailed this question. Now you got to understand, kids. There's like 7 math teachers in my building that are going to sit in one room. Sometimes we might be up to 8 math teachers sitting in one room grading like 400 exams. And as you can imagine, math teachers are kind of nerdy. Oh, I know you don't believe it. I know you don't believe it. Well, we're kind of nerdy. And we're a little weird. And some of us even more so than others. So we sit in a room with nerdy people reading nerdy exams. Some are good, some are terrible. And it's sort of nice to have a little note written to us once in a while. Dear Mr. or Mrs. Grader. Because remember, your teacher can't grade your test. So I can't look at any of my kids' tests. I'm just looking at somebody else's. So I told my kids to write the grader's notes. And I said, you know what? Tell the grader that you nailed this question. Say, don't even look at it. It's gorgeous. It's beautiful. It's perfect. Tell him, Mr. Krause was the bomb teacher. I nailed that question. If you don't know how to do it, though, don't tell him you nailed the question. He's still going to look at it, or she's going to still go at it. But write him some notes. Write him some, have some fun. If you get bored, have some fun. H of x, by the way, it's, yeah, you got it, man. It's equal to y. So we're going to switch the x and y. I'll try to even actually do that this time. X is equal to y cubed plus 10. Still got to get y by itself, so I will bring over I will bring over the 10 and I get x minus 10 equals y cubed. Now, in order to get rid of a cube, you have to take a cube root. So I get y is equal to the cube root of x minus 10. I'm going to do another problem over here in just a second. So I want to write h inverse of x equals the cube root of x minus 10. I'm going to add a question, so we'll call this question 9.5. And our function, I'm just going to call it y equals x squared plus 6. All right? Now to solve this one, and I want to know what the inverse of this is, so I'll switch the x and y. I needed to put a question on this. You need to pay attention to this. I know it's not on your sheet, but pay attention. X equals y squared plus 6, because I switched the x and y. Now I'm going to solve. I get x minus 6 equals y squared. Now in this problem, you have to do something ever so slightly different. In order to get rid of the squared, I'm going to take the square root. But with square roots, with even roots, you must put a plus or minus. So y is equal to, and let's say I originally called this f of x. Y is equal to plus or minus the square root of x minus 6. Or, as your final answer, f inverse of x is equal to plus or minus the square root of x minus 6. So make sure that when you're taking the square root, you put a plus or minus. Oh my God. These are awful. They're terrible. You know the cool thing about absolute values, and this is why we invented absolute values, is just really to mess with kids, because it's a lot of fun actually. But the wonderful thing about a simple question like this is it's actually two problems. It's like a fooled you. You're like, man, I got one problem. No, you got two problems. So absolute values always give you two problems. Always. That's because we like to sneak in an extra problem or two, because we don't have anything else to do. We might as well give you more problems to do. Remember, we're nerds. We have no lives. We sit at home and try to figure out all the different ways to make your life miserable. So let's see if we can start with what we got here. We got 1/2 absolute value of 2x minus 4 greater than 3. You may not start to solve. And by the way, anybody distribute it into an absolute value, seriously, take this pencil and just kind of jam it right here a little bit. Not too hard. Just enough to kind of like leave an indentation or something, so you don't do it again. You have to get the weird thing alone. In this case, the weird thing is just this absolute value. We want to get this absolute value all by itself. Man, I feel like a Zamboni there. So I'm going to multiply both sides by 2 just to get rid of that fraction. So now what I have is the absolute value of 2x minus 4 is greater than 6. And now you got two problems to do. And at the end, you have to decide, is it going to be an and or an or? So, problem number 1. Problem number 1 is right there. It's 2x minus 4 greater than 6. And you can solve that. 2x is greater than 10, or x is greater than 5. That's part of the problem. Excuse me, that's part of the solution. But that's just the first equation. Now you have to solve the second equation. You have to deal with the negatives, because if I take the absolute value of a negative, it's positive. So you have to do two separate equations. Now, you don't mess with the left side. Don't touch the left side. Can't touch the left side. Can't touch this. No, can't touch this. But everything else switches. So it becomes, and I'm going to do it in red so you see it, it becomes less than negative 6. So this gets switched and this gets switched. So now I'm going to get 2x is less than negative 2 when I add 4. Divide by 2 and I get x is less than negative 1. Now I got to decide if this is an and or an or, and it's impossible to do. Not impossible, but it's difficult to do without an graphing it. So let's do 0 here, negative 1, negative 2, 1, 2, 3, 4, 5, 6. There's 5. So here we got less than negative 1. So we're going to do an open circle and less than. And we got greater than 5. Open circle going to the right. Now look, if you're pointing in two different directions, I could be a good kid or I can be a bad kid. I can listen to what my mom says. I cannot listen to what my son says. I'm at a party that is drinking. I can go home, or I can stay here and be a loser. Or you have decisions to make. Do I go good side? Do I go bad side? But you have decisions to make. So this is an or. So I could write the word or here. This would be what's called standard notation. My graph is perfect, and it's x is greater than 5 or x is less than -1. In this particular case, and I don't remember if this is actually on the readings, so I can't remember. That's really weird. I probably should know that. But it's interval notation. You learned it this year. So I'm going to whatever you call it, revisit it, relearn it, redo it. So this part, in interval notation, x is less than -1 would be negative infinity to 1, -1, parentheses. You can't equal infinity, and it can't equal negative infinity. The union symbol for or, 5 to positive infinity. And that's interval notation. All right, so I've got -2, alert, 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 alert. God, I'm like on fire with annoyingness today. The thing that I'm alerting you for is this negative, right? We're going to divide by negative. We're going to divide by negative. And you guys have been told all of your lives, or at least the last couple of years, that when you divide by a negative and you're working with inequalities, what must you remember to do? Oh, that's right, John. Nice job. Leela, you're amazing. Flip the sign. Flip the sign. Now that you've isolated the weird thing, remember our goal was to get the weird thing alone. The weird thing in this case is the absolute value. We did that. Now I'm going to split it up into two problems, 1 and 2. I rewrite the original. I don't know why I did that. That's not the original. I rewrite the original. X minus 5 is greater than -6. I'll solve that. X is greater than or equal to -1 when I add 5. And then I'm going to come over here. Now, I still don't know if this is an or an and, but I'm going to write x minus 5, and then I'm going to put what I'm going to change in red. It's going to be less than or equal to positive 6. In this case, x is less than or equal to 11. So I still don't know if this is an and or an or. So here's -1. There's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So close circle at -1. Arrow going to the right. Close circle at 11. Arrow going to the left. So this is an actual and. Now, to put this in standard notation, you'd put the left number, -1. It's always less than or equal to x, because the x has to be in the middle, always less than or equal to, or just less than. In this case, it's less than or equal to. So this would be standard notation. In interval notation, because I can equal both, I put bracket, -1, comma, 11, bracket. All right, now let's get to these ones. These are rational ones. These are not quite as easy. These are a little more complicated. Can you hear me now? Let me just make sure I'm recording. And you hear me now? Can you hear me now? Yes, we're recording. 38 minutes. We're doing good. So with these ones, which are ever slightly more complicated, I need to change this problem, mostly because it's stupid, or because I think I'm pretty sure a number didn't come out. Let's go into here, 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 here. And this is number 3. I'm pretty sure none of the numbers didn't come out. I think there should be a 0 at the end here. I just want to make sure. And if it's not, I'm going to correct it right now. So you get to hang out with me. You get to watch my geniusness at work. Oh, it's a 15. Yeah, that would make sense. It's a 15 out of. Okay, so it's fine. It just didn't come out in the sheet. So I want to put that. I don't know why I was thinking 10. I should have known it was a 15. That should be a 15. Okay. So what we want to do now is we want to factor this. So what we have here is x minus 5, x plus 3, all over x minus 1. So we get 3 critical numbers, and I'm going to do those in blue. Our critical numbers are x equals 5, x equals negative 3, and x equals 1. Now, these two make this fraction equal to 0. This one makes the fraction undefined. So those are our 3 critical areas to test. It actually breaks it up into 4 critical areas to test. So I need to get those on my number line. So here's negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. So I have to decide on open or closed circles on these. Well, I'm going to do that right now. I'm going to take care of that issue right now. On the 5s, because if I want equal to, and I've got an equal to here, on the 3 and the 5, since those can be equal to, I want to put solid circles. But this has nothing to do with being equal to 0. This number comes from because it makes the fraction undefined. So I want to leave an open circle on this. And I should have put like a negative 4 out here. So what I want to do now is I want to show you something. I want to break this up into 3 test areas, 4 test areas. To the left, in between, and to the right. So I'm going to test a number way out here. I'm going to test the number x equals negative 10. Now what I'm going to do is I'm going to store that in my calculator. Negative 10 stow x. And then I'm going to type in the original equation, which was x squared minus 2x minus 15 all over x minus 1. And I'm going to hit enter. Well, the only thing I care about is the fact that this says it's negative. Negative. Now I come back over here. What does this mean? This says greater than 0, which means positive. Well, over in this area, everything is not positive. It's negative, negative, negative. So this is not going to be an area I want. I'm going to guess this is. So now I want to try a number in here. I'll try 0. So I'll take 0 and I'll store it into x. Now the cool thing is I've already typed this in once, so I don't have to do this twice. Hit enter. Hopefully this will turn out to be positive. It is positive. So in between here is positive, 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 positive. Now I'm going to guess in between here is going to be negative because it always goes back and forth. But let me check. 2 Control var x and hit up. It is in fact negative, so in this area it would be negative, 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 and if you tried, this area would be positive. So what do I want? I want the area where it's positive, so I'm going to connect these two, and I'm going to point from here out, going this way. So the answer to my question is negative 3 is less than or equal to x is less than 1, or x is greater than or equal to 5. Now that's not interval notation, this is standard notation. If I had to do it in interval notation, I would put bracket negative 3, comma 1. No, not bracket here, this would have to be a parenthesis, because I can't equal 1. Union, bracket 5, comma infinity. All right, that one's done. All right, so, and again, we're missing a doggone number here. I don't know what it is. It's a 0. So we're missing a 0 this time. I don't know why it's dropping off these zeros. Okay, so in the numerator, if I factor it, I get x times x plus 7 all over x minus 5, x plus 2. So in this case, I actually have 4 critical numbers. X equals 0. X equals 5, or excuse me, 7. Oh, I do have x equals 5, and x equals negative 2. So I got to go from negative 2 to 7. So negative 2, let me do this in red. Negative 2, and it makes it negative 3. Negative 2, negative 1, 0 is one of my numbers. 2, 3, 4, 5 is one of my numbers, 6, and 7 and 8. You don't have to put numbers on everything. Okay, so let's talk about this. 0's okay. It makes the numerator equal to 0, and that's fine. And 7's okay. And I have equal to here. So on 0, I'm going to put a closed circle, because that would make this whole fraction equal to 0. And 7 would make this fraction equal to 0. But on the 5 and the negative 2, it can't equal 0. It cannot equal 5, and it cannot equal negative 2, because that would leave my thing undefined. So I actually have 5 testing locations. Now the good news is they pretty much go back and forth. So let me try like negative 10. So x equals negative 10 will be the first one I try. Go back to my calculator. Good news is I put that in already. There it is. Enter, enter. And then I'm going to type this crazy fraction in. Control division. X, oops, not that. Control division. X squared minus 7x. All right, so let me erase all this, because this is all messed up now, because I just realized I made a mistake. I realized as soon as I pressed it in, I did this. Okay, this should be a minus 7, because that's what minus 7 would make this undefined. So we should go from negative 8, negative 7, negative 6. Sorry about that, kids. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Sorry about that. And that's 5. All right, so at 0, that's okay. At negative 7, that's okay. 5, not okay. Negative 2, not okay. I'm still going to try this x equals negative 10 to see if this works. So I'll go back to my calculator. X, and this should be x plus 7. All over x squared, was it minus 3x minus 10? I don't know if it was minus 3x or plus 3x. Minus 3x minus 10. And I'll hit enter, and it is positive. So in this area, it is positive. And that's what I'm looking for, positive. So check. Now I'm going to check negative 5. So negative 5, control var x, enter. And I want to see what is going on this function. This function is now negative. I do not want negatives. In this area, it's negatives. Not a good spot. Let's try negative 1. I'm going to guess negative 1 is, in fact, going to work. Positive. Good. Positive, 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 positive. This will be negative, 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 and this would be positive, positive, positive. So that's just the way it would work. So what do I want? I want when it's positive. So I want from here out, i.e. then I want from here, and then I want from here out, because that's all the areas where it's positive. So get rid of this and put my answers. I'm going to put my answers in standard notation, and I'm going to put my answers in interval notation. So x can be less than or equal to negative 7, or negative 2 is less than x is less than or equal to 0, or x greater than or equal to 5. Now in interval notation, negative infinity to negative 7, inclusive, union, negative 2 comma 0, inclusive for the 0, union, 5, inclusive, comma, infinity. Oh, wait, no, 5 makes a problem. I can't have a 5, so I can't have a solid circle. That means this has to be a parenthesis. All right. Ooh, that was a pain in the neck. All right, we're back to some easy ones. Isolate the weird thing. Weird thing's isolated. Now we just split it. Should have done these first, right? Negative 4x plus 5 less than 13, or, now I don't know if it's an or an and, but we're going to go negative 4x plus 5 is greater than negative 13. Notice just the sign flips around and this sign changes. All right, so I solve this. I get negative 4x less than 8. X, wait, now we're going to divide by negative 4. We're going to divide by negative 4, so I get x greater than negative 2. going to subtract 5. I get negative 4x is greater than negative 18. And then I'm going to divide by negative 4, divide by negative 4, and I get x is less than 9 over 2, or that's 4.5. Oh, I can't be right. I got a fraction. Oh, man, shut up. I just don't know if this is an and or an or until I get a good idea of graphing it. So here's negative 2, open circle going this way, greater than, and here's 4.5 or 9/2, open circle going this way. So it's an and because we're connecting the dots. So in order to give the answer, I have to say negative 2 less than x less than 9/2. Done. Isolate the weird thing. It's isolated, so now we're going to split it. The original 7 minus 2x greater than or equal to 9, exactly as it is with no absolute values. And then we're going to isolate, then we're going to go 7 minus 2x. Notice we don't mess with the left side, but everything else changes. So this gives me negative 2x is greater than or equal to 2. Divide by negative 2, divide by negative 2, and I get x is less than or equal to negative 1. Subtract 7, I get negative 2x is less than or equal to negative 16. Divide by negative 2, divide by negative 2, and I get x is greater than or equal to 8. I'm not sure about this, but I think it's an or. We got a negative 1 down here, closed circle going this way, and I have an 8 here, closed circle going this way. By the way, you would never have two arrows going in the same direction. You must have screwed something if that's true. This is clearly an or. Do I want to be good or bad? Be good. Got enough bad people in the world. But I got to give my answer. Oh, did I give my answer up here? I did. Didn't say how I should give it, so I'm going to give it the way I did. So x is less than negative 1 or equal to, or x is greater than or equal to 8. All right, this one's a little tricky. I'm going to solve and graph it on the, so all I got to do is solve it and graph it. So divide by negative 3. We've got to isolate the weird thing. Can't touch this until you do. But because even at the beginning you divided by a negative, that sign has to flip. So it's going to be 6 minus x is greater than 5. Now you split it up. 6 minus x is greater than 5, or 6 minus x is less than negative 5. This gives me negative x is greater than negative 1 when I subtract 6. Divide by negative 1, I get x is less than 1. This one gives me negative x is less than negative 11. Divide by negative 1, I get x is greater than 11. So I got to graph it. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That 10 was terrible. They should be relatively evenly dispersed here. 10, 11. So this is 11. Open circle going to the right. Open circle going to the left. I'm not done until I've said my final answer. X is less than 1 or x is greater than 11. This is part of the solution. That's the answer. And there's the graph. All right. Solve for all values that satisfy this equation. Let's see. Is there a GCF? No. Now, for my kids, you can come over here. I'm relatively certain, based on the title of this, that this is not going to factor. Menu 3, 3, 1. You can always tell if something's going to factor very quickly by coming over here. Menu 3, 3, 1. You got 3, 18, 32. So 3, 18, 32. See how it says empty set? Not only is this not going to factor, the answer must be imaginary, because this does not work. So we're going to figure this out. We're going to go A equals 3, B equals 18, and C equals 32. Now D is my discriminant, which is B squared minus 4AC. So that's 324, that's 18 squared, minus 4 times 3 times 32. No idea what that's equal to. So 18 squared is 324. So 324 minus 4 times 3 times 32. Negative 60. Now remember, when the discriminant is negative, you have imaginary roots, which means your answer has to be in a plus bi form. And I probably should have put that in the directions. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac, otherwise known as the discriminant, divided by 2a. So x equals negative 18 over 2 times 3 plus or minus the square root of negative 60 over 2 times 3. So if I come over off this side and think about this negative 60, the largest perfect square that goes into that is 4, believe it or not. So negative 4 times 15. Now the square root of negative 4 is 2i. So this thing here becomes 2i square roots of 15. So I simplify it. X equals negative 18 over 6 plus or minus 2i square roots of 15 over 6. Almost finished. X equals negative 3 plus or minus I square roots of 5 over 3. I'm just curious because, I can do that too. Menu 3, 3, 1. I can figure out imaginary roots, but I'm going to just have to tell it it's complex. And it was 3, 18, 32. And it says C polyroots. And negative 3, that must be square root of 5 over 2. And then negative 3 plus. So whatever. It worked. Got 3 left, kids. No, man, I got a lot more than 3. Oh my God, I thought I was at 20. I'm going to guess this one's not going to work. I think we have to use the quadratic formula on all these. A equals 3, B equals 5, C equals 7, D, which is the discriminant, is B squared, 25, minus 4 times 3 times 7. So let's see. 25 minus 4 times 3 times 7 negative, what the? 25 minus 4 times 3 times 7, negative 59. Well, the good news is that's prime. So I get x equals negative b, negative 5 over 2 times 3, plus or minus the square root of negative 59 over 2 times 3. Well, 59 is prime. That's the good thing. So it's negative 5 over 6 plus or minus I square roots of 59 over 6. Done. I don't think this one works either. This one actually might, but let's just do it anyway. We're going to do all these by the quadratic formula. Maybe it'll factor, maybe it won't. C equals negative 3. Now the discriminant here is b squared, which is positive 16, minus 4 times 3 times negative 3. So 16 minus 4 times 3 times negative 3. 52. So I get x equals negative b, which is 4 over 2 times 3, plus or minus the square root of 52 over 2 times 3. Well, the square root of 52 does have a perfect square that goes into it. It's the square root of 4 times the square root of 13. You know how I remember that? Deck of cards. Deck of cards has 52 cards in a deck. And there's 4 suits. So 2 square roots of 13. So I get x equals 4 over 6 plus or minus 2 square roots of 13 over 6. And I just simplify it. X equals 2/3 plus or minus the square root of 13 over 6. Because 2 goes into Oh, not over 6, over 3. 2 goes into 6 3 times. So A equals 10, B equals 13, C equals -3. The discriminant is equal to 169 minus 4 times 10 times -3. So calculator, 169 minus 4 times 10 times -3. 289. I'm relatively certain that's a perfect square. 17 squared. By the way, if you raise something to the 1/2, it's the same as taking square root. So this becomes x equals -13 over 2 times 10 plus or minus the square root of 289 over 2 times 10. Now, this isn't going to work out to be a beautiful answer, so I get x equals -13 over 20 plus or minus 17 over 20. So you can't finish this one. You have to continue on with this one. And I'm going to show you how to check it using your calculator. But I get two answers. I get x equals, when I subtract -13 minus 17, I get -30 over 20, which is -3/2. And when I add this, I get -13 plus 17. That's 4 over 20, which is 1/5. Let me check this. 10, 13, -3. So menu 3, 3, 1, 10. I forgot already. 13, -3. 13, -3. 13, -3. So -3/2 and 1/5. There they are. All right, almost done, kids. Well, see right here, it screams imaginary. You don't want to have a negative x squared, so everything's going to that side. So we end up with 4k squared minus 64k plus 256 plus. Sorry, kids, I'm tired. I'm going to make a mistake. 272 is equal to 0. So A equals 4, B equals 64, C equals 272, and D is a pain in the neck. I don't even know what D is. 64 squared, 4096 minus 4 times 4 times 272 minus 4 times 4 times 272. Oh, that's not too bad. -256. So -256. So I get x equals, remember we're dealing with this one now. Negative b is 64 over 2 times 4 plus or minus the square root of -256 over 2 times 4. Well, you may not know it, but 256 is a perfect square. I'm going to raise this to the 0.5. Oops. 256 raised to the 0.5 is 16. So I get x equals 64 over 8 plus or minus 16i over 8. So my final answer is x equals 8 plus or minus 2i. Now, believe it or not, I believe this one can be done using, I'm going to do this one also using completing a square. Oh, I said using completing a square. Oh, I'm sorry. Well, I did it not using completing a square. Now let me do it using completing a square, because I think completing a square would be a lot easier. So I get this. Now, the idea with completing a square is, first of all, the leading coefficient has to be 1. So I got to divide through. So I get k squared minus 16k plus, I have no idea, 272 divided by 4, 68. 68 equals 0. So I have to get the constant over the other side, so negative 68 plus square, completing a square, square. What goes in the parentheses is this half of it. Here goes 64 squared. So 64 goes here. So I get equals negative 4. Now you'll see this is much easier. I take the square root of both sides. And when I take the square root, I put a plus or minus. So I get k minus 8 equals plus or minus 2i. I bring the 8 over, and I get k equals 8 plus or minus 2i. I think that's why I actually had to do it the quadratic, or used completing a square, because it was so much easier than that other way. All right, so we're going to do completing a square 2 more times. So I'm going to divide through by negative 3. So I get k squared plus minus 16k, let's see, 192 divided by 3, 64. So plus 64 equals negative 9. I got to move the constant over, so I got to bring the 64 over because that's the next step. So I get k squared minus 16k plus square equals negative 73 plus square. So k minus 8 squared, half this, and goes in here 64, and 64 is equal to, what is that, negative 6, negative 9. So now I take the square root of both sides. When I take the square root, you put a plus or minus. So I get k minus 8 equals plus or minus 3i. Square root of negative 9 is 3i. And my final answer is k equals 8 plus or minus 3i. Last problem, kids. Last problem. Got to divide by 3. Cannot have a leading coefficient. So I'm going to divide. So I get x squared plus 6x plus square is equal to negative 21 plus square. What goes in the parentheses is half of this, which is a positive 3. Goes in here squared, 9. So I get x plus 3 squared is equal to negative 12. So I take the square root of both sides, and I put a plus or minus. Now the square root of negative 12 is equal to the square root of negative 4 times 3. Well, the square root of negative 4 is 2i. So this becomes 2i square roots of 3. So finally I get x plus 3 equals plus or minus 2i square roots of 3. Bring the 3 over. I get x equals negative 3 plus or minus 2i square roots of 3. And that's it. That's all she wrote. Again, if you like what you see and it helped you out, hit the subscribe button, hit the thumbs up, not the thumbs down. Thumbs up improves your grade. Thumbs down just makes me sad. I don't want to be sad. If you get 100, email me, kenkrause@gmail.com. I can't wait to see how many kids get 100. You guys keep working hard. You keep studying. You keep putting your head down. You got 5 days left. Monday, Tuesday, Wednesday, Thursday. Bam. Test day. Good luck, kids.